Dear students, welcome to EPG Pathshala. I am VN Prabhakar, visiting faculty at the Archaeological Sciences Center, IIT Gandhinagar. In the paper Pre- and Protohistoric Cultures of India, we will be looking into the module Technologies in Ancient India. At the end of this module, you will be able to understand some of the ancient technologies which were in India, and also to trace back the origin and development of technology to the earliest times, and also to understand the continuity of technology which led to later period developments and advancements. Technology as such, it was not initially the application of scientific knowledge to the practical aims of human life. Rather, technology, it generally came first. If we look into the earliest examples of technology, the stone tool technology might be the earliest. The prehistoric humans, they were fashioning various kind of stone tools from the pebbles and other kind of stones available within their vicinity, and the earliest dates goes back to 2 million years ago in the South Asian context. Also from Athrambakam, the date of 1.5 million years for the prehistoric age, we have a very good stone tool technology in this part. And the human presence is also there in the South Asia. We have the Narmada man in Narmada Valley of the archaic Homo sapiens, and also another evidence of the modern Homo sapiens in the South Asia coming from Fahian cave in Sri Lanka that can be datable to 35,000 BP. So among the stone tool using communities also, we see a major shift in the technology from large stone tools to smaller stone tools. The microliths which appear some 30,000 years ago, they were very small in size when compared to the earlier lower Paleolithic tools, and these kind of evolutions, emergence of technologies one can see, and ultimately they were used for hafting in bows and arrows, and also for spears for long distance hunting. This also saw the emergence of agriculture. Agriculture is another technology in which the humans discovered the advantages of planting various kind of seeds obtained from the wild plants, and they could develop a very good continuation of food supply, so that food can be available throughout the year, not just they have to gather the food and obtain it for a very short period of lifetime. Now they can go on growing these crops, and they can also domesticate animals so that they can have a year-long supply. We have evidence of wheat and barley being cultivated, domesticated varieties of wheat and barley from the Neolithic Mahargad in Pakistan, and also we have in the Gangetic Plains, we have the earliest domestication dating back to 7th and 6th millennium BCE, and also the presence of rice. Rice cultivation is documented in the Middle Ganga plain from site known as Lahuradeva, datable to the 7th millennium BCE. Also, we saw the emergence of ceramic technology at the site of Mahargad. It emerges in the 7th millennium BCE. Similarly, in the Ganga plains, we have emergence of pottery from around 6000 BCE to 5000 BCE, and lately several sites in this region we see the emergence of pottery, and they were making initially very crude pottery, and later the wheel made pottery emerges, and various kind of technologies and control of fire which led to the development of sophisticated pottery. We have evidences of construction mechanisms also in the ancient period. If we trace back the kind of technology existed in the ancient period, the Harappan civilization is the most important things. We have very big monumental buildings in the form of a great bath, which is extensively spread out and constructed using large bricks of some specific ratio, 1:2:4 ratio, which was used by the Harappans, and an elaborate drainage system also existed. In this, you can see how the drainage system is emanating, and adjacent there is a well also, and there is a sump also. So they have a mechanism of draining larger tanks. Just in the case of a great bath, the great bath, if it has to be drained out for cleaning purposes, it is connected to a very huge drain. Even a human can very easily pass through, and intermittently they had sumps so that it can be cleaned also. They were using a type of trapezoid bricks, wedge-shaped bricks for constructing wells. This is very common even during the modern period. These kind of bricks, they give a roundish form so that the outward thrust, whatever coming from the surrounding earth, it cannot make the well to collapse. The inward collapse cannot be possible. So these kind of bricks, they are very common during the Harappan period for the wells construction. We also have very good evidence of the transport system. Transport system, it can be very easily understood during the Harappan civilization. Again, that is the earliest urban society of South Asia. We know that kind of transport system in the form of toy carts available, their carriage system, the wheels are available, the kind of open carts are available, toy cart frames which we obtain from the archaeological context. It can be used to reconstruct the kind of carriageways. So these kind of evidences are available from several Harappan sites in India like Banavali, Rakigadi, Dholavira and Kalibanga. So this help us in understanding the kind of transport mechanism available nearly 4,000, 5,000 years back. We also have evidence of a sea trade. I mean, we have depictions on the tablets, terracotta tablets, the kind of ships which could have been available, and also the river boat could have been available with a flat based river boat which is depicted on a tablet from Mohenjo-daro. We get a very good idea, and it is very much similar to the modern river boats of river Indus. And of course the evidence from Lothal, the dockyard from Lothal, it gives a very good understanding of how smaller boats coming from the high seas or from the interior channels, they can be diverted into this dockyard and the goods can be loaded and unloaded through this system. Metallurgy is another important technology which emerged very early, even before the Harappan civilization. During the Chalcolithic phase, we have evidence of a large number of copper tools and implements and ornaments which have been produced by smelting, which have been procured from the raw material sources, and they have been smelted and melted and produced into various kind of tools and implements. Like you can see the kind of bronze tools from Mohenjo-daro. Copper was mixed with tin, arsenic, nickel and lead in varying proportions to create bronze. Similarly, copper was also used to manufacture vessels. The evidence from Mohenjo-daro and Harappa, it clearly shows the kind of pots and plates which have been produced, and copper tools like axes, spearheads, arrowheads from Dholavira clearly indicate the kind of technology they were into. And they were also fashioning even animals, smaller kind of bull from Kalibanga. It's an example of bull from Kalibanga which was fashioned out of copper metal. The famous dancing girl from Mohenjo-daro, it is another example of the lost wax technique in which the bronze casting was done by the Harappans. This is a very clear example of the casting technique which the Harappans might have mastered, and they were producing this kind of objects out of copper and bronze. Traditions also existing, how the traditional technology was available even up to the 19th century. We have depictions by the travelers like the Britishers. They were depicting how in the traditional areas they were still smelting the copper. Like you can see a simple copper furnace at Khetri in Rajasthan. Khetri is one of the most important copper yielding raw material ore source in India, from where copper is extensively exploited for manufacturing of various tools and implements. So one of the contribution of the Indian metallurgical splendor is the manufacture of this bronze Buddha figure. It's a very huge one. It is one of the largest. It was found in Sultanganj in Bhagalpur district, Bihar, and datable to 500 to 700 CE. It is now housed in the Birmingham Museum, and again it was made by lost wax method. It is a very important kind of technological advancement. You can see this kind of 2.3 meter high and 1 meter wide bronze sculpture weighing nearly 500 kg was manufactured using this technology. So this is the kind of sophistication the ancient metallurgists obtained in ancient India. Another examples of bronze come from South India. The South Indian bronzes starting from Pallava period onwards are excellent evidence of high craftsmanship and the kind of sophistication they have achieved. So the largely Nataraja images of this kind we find from the Pallava as well as early Chola and late Chola period dating from around 8th century CE to around 11th 12th century CE, and slightly during the later period in Vijayanagara period also some sort of bronzes were manufactured. So this is an excellent example of metallurgy in ancient India, and even today some of the artisans in Tanjavur district, they still follow the same kind of lost wax mechanism which was followed during the Chola period. Another example of high workmanship is this kind of bronze mirror. It is height in bronze mirrors which are still manufactured in some parts of Kerala, known as Aravallis mirrors, which has a slightly high percentage of tin, which gives the high reflectiveness, and this is the Aravallis mirrors, which is very famous and also high value metal products. And again, this shows a continuity. It is not that they have discovered in the recent past. It is a long continuity which could have existed thousands of years back, and it is traced now also, and so that the people can reproduce them, so that to understand the ancient technology available with them. The emergence of iron. Iron in ancient India is an important technological advancement because iron comparatively is harder to manufacture. Smelting, even though it is comparatively easier, but it has to be smelted at high temperatures, and sites in North India and with dates going back to 1700 1800 BCE, several sites in northern India which have been documented and excellently excavated and brought to light by Dr. Rakesh Tiwari is one of the crucial evidences here. We can understand the growth of iron technology in India from the sites known as Dadupur, Lahuradeva, Jhusi, Malhar and Raja Nalka Thila. So these are all important sites which have yielded furnaces also for smelting iron. So this is one such evidence from Malhar in district Chandoli, Uttar Pradesh, where a iron smelting furnace has been exposed, and some of the iron tools which have been found from this site. These are examples of iron metallurgy in ancient India. We also have evidence of iron furnaces from sites like Naikund, and this is a reconstruction of how iron furnace would have looked like. I mean, the kind of evidence available at Naikund, it is datable to the 1000 BCE of the megalithic period. From the availability of the basic plan of the furnace, it has been reconstructed to look into like this form, and this is more or less the same kind of form in which some of the tribals in this part of the region, in Chotanagpur region and other parts of India, they manufacture, they smelt the iron with using a more or less a similar technology. Coming into the historical period, there's a long continuity, and during the historical period everything has been codified, as has been reflected by the Arthashastra, Kautilya's Arthashastra. He gives a detailed description of how the superintendent of mine should perform, what kind of knowledge should have, what kind of minerals he could collect, and what kind of byproducts are produced, and how it should be processed and used for producing various kind of metals, and depending upon the availability of raw materials, the quality of the raw materials, and also to determine the quality. So all this kind of information, it is available from the literature, and how different officials were responsible for kind of supervising this work. It is also clearly depicted in the literature. Iron was also used for making this kind of sculptures, but again it was concealed with gilding work. Here you can see a wrought iron Buddha. It has been gilded with the aid of a very small percentage of gold, so that it can appear like that of a gold statue. So this kind of technology was also in existence, and due to the presence of large iron ore sources in India, India was able to produce a high quality iron. High quality ingots were produced, and it was exported to the Western world, and it has been estimated that in the late 1600s, shipments of tens of thousands of woods ingots, high carbon steel, which was produced exclusively in India, and it was exported to the Western world. India's iron and steel industry was very intensive until the 18th century. So some of the sites from South India, from where we get evidence of the wood steel. Wood steel, which I have told earlier, it is a high carbon steel. It is very hard, and it was suitable for producing swords and knives of various weaponry, so that it can survive for a pretty longer period. So these kind of things were produced, and a typical carbon content in wood steel is around 1.5%. So it has been estimated, like people were not knowing about the wood steel in the European context. I mean, they were knowing only about the Damascus steel. They know only the Damascus steel because the wood steel which was manufactured in India, it was traded into Damascus region of Syria, and from there it spread into the entire world. So the Westerners, they were knowing only about the Damascus steel, and it was highly prized, and it was renowned for its sharpness and toughness. But unfortunately, the Indian woods industry died during the 19th century. But the Britishers and other metallurgists from France and Italy, they tried to master the secrets of wood steel from 18th century onwards. And these researchers, they led to the understanding of the importance of carbon in steel, and it also helped in the emergence of the new steel making technology. We have weaponries of the Mughal period, high workmanship, and also the strengthness and hardness, it is indicated by the wood's steel. These are the best products and the best weaponry which were available in the entire world. The Britishers, they were highly impressed when they saw these kind of weaponry, and they were commented that this could be the best kind of steel available in the entire world. So that was the high quality of Indian steel. Again, living tradition, it also tried to maintain the kind of standards, and we have several craftsmen working in West Bengal, Kerala, Tamil Nadu, Jharkhand and Bihar, who have tried to emulate the kind of ancient technologies, and the metalworking communities, they were also helping in the Indian economy, and we can even compare some of the technologies. Delhi Iron Pillar was one more technological marvel which the ancient Indian metallurgists they produced. So we can understand the traditional smelting process by looking into the kind of technologies they use, how they collect the iron-rich material from the particular places, then how they heat it and produce certain kind of steel. So this can be very well understood. The tribals which are engaged in producing this kind of traditional technology can also be studied to a larger extent, and we can understand the ancient technology prevailed during the period. And the kind of implements they were using, they use a variety of implements. The terracotta tuyers are the pipes in which the smoke emerge and the slag emerge. So this kind of identifications can be made, and if we find it from the archaeological context, we can correlate it very easily, and what kind of metal manufacturing use it was put into. So these kind of things can be very easily understood, and even the importance of supply of oxygen by simply pressing the bellows. Bellows were used, either leather made bellows or other bag bellows. They were used for supplying oxygen for the furnace. As I told, one of the marvels of Indian metallurgy is the Delhi Iron Pillar, which was extensively studied by the metallurgist late Professor R. Balasubramaniam of IIT Kanpur. He has conducted extensive research on the technology, how it was forged together. It was a forging technology, and how a protective layer is formed over the iron pillar consisting of phosphorus and oxygen compounds to make it rust proof. Similar examples of iron pillars we also have from other places, like from Dhar in Madhya Pradesh. We have a similar iron pillar. It is about 15 meter and datable to the 13th century. The Delhi iron pillar, it is datable to the 4th century CE. But this shows the continuity from Delhi iron pillar to Dhar iron pillar, and from other places also we trace the continuity of the metallurgical wealth of ancient India. As I told, iron beams and beams were used extensively in places like Konark Sun Temple, where they were used for holding the superstructure at certain places wherever wooden beams would not have served the purpose. We have evidence of these iron beams lying near the Konark Sun Temples. Konark Sun Temple is datable to the 13th century CE, and that's how we are tracing the continuity of the iron technology in India. Another example of the iron metallurgy is the cast iron cannons. I mean, we find a large number of cast iron cannons in many of the forts. If you go to many of the forts in South India, North India, in Maharashtra, you will find large number of cast irons. So these are made with a different technology. At some places they were cast, at some places several portions were cast and forged together to produce a big cannon. One such example you can see at Tanjavur Fort in Tamil Nadu, which is shown here. So understanding the ancient rust-proof protective layer from Delhi iron pillar. So the modern metallurgists, they were also engaged in producing various kind of elements, various kind of compositions, so that modern materials can also be rust-proof. Like in the case of railway lines, I mean the rails, they have to be high resistant, they have to be rust-proof. That's how it can survive for a very longer period. So the analysis conducted on various composition, it has indicated that a chromium, copper and nickel composition, it has produced a high quality rust-proof rails that can be used for the Indian railways. We also get excellent evidence of the ancient metallurgy in the form of ancient mines and pits. For example, in the regions of Zavarmala, Dariba, Agucha and the Khetri areas, we have excellent evidence of the mining of copper-rich, lead and silver-rich ores for a pretty long period. And some of the mines in Rajasthan, it dates back because there are examples of wooden beams still preserved inside these mine shafts, and they are datable with the radiocarbon dating, and they have been dated to around 3rd millennium BCE. So it is a very long tradition of mining with shaft mining and producing these kind of ores for various finished products. Zinc technology is another important technology which emerged somewhere around 1st millennium BCE in India, but we have evidence from slightly from a later context. But from the Zavarmala region, the excavations conducted by the MS University, Baroda, they clearly indicate the kind of downward distillation technique, because zinc, it has a very low boiling point and it tends to evaporize while its ore is melted. So in order to trap the vaporized zinc, they have to use a different technology. They have to use a downward distillation technique so that the ore is heated in the upper chamber and it slowly condenses and it is collected in the lower chamber. So this kind of indigenous technology was developed by India, and it mastered, I mean, thousands and thousands of tons of zinc was produced at Zawar mine area in Rajasthan. Coming to a different technology, and in India we have a very ancient tradition of producing stone beads in the Harappan context, and even before the Harappan context we have examples of the stone beads employing various kind of technologies. The longer beads were perforated using a more tougher material known as earnestite. So these technologies were developed by the Harappans. Harappans, they are also exponents in the faience technology. Faience is a precursor to glass, and it was manufactured from the crushed quartz particles mixed with various coloring agents like malachite to produce a bluish green or bluish color. They were also producing etched cornelian beads in which decorations in white color they were produced over the red color stones. Glass technology is another technology which emerged during the 2nd millennium BCE in India. Again, as you told you, you have seen how faience was produced by the Harappans. So faience is the precursor of glass, and simply varying the components, one can produce a high quality glass which is transparent and it can be colored to any desired color, so that slowly replace the stone which was very hard to perforate, and glass became a dominant material for bangles, beads, ornaments during the 1st millennium and during the historical period. Extensive research has been conducted on the manufacture of glass, how the traditional technology is also being used at places like in Andhra Pradesh. There is a place known as Papanayadupet where they still produce glass in the more traditional technology. So this also helps in knowing the continuity in the glass manufacture in India. And during the ancient period, they were using several type of gems. I mean, it is also known as the Navaratna, the 9 precious gems. It consists of diamond, pearl, ruby, sapphire, emerald, coral, topaz, and lapis lazuli, and even many more are added to this list. But 9 precious stones, they are very famous in the gemology and exploited by the ancient people for producing various kind of gems and ornaments. Writing materials is another area in which technology was used to process and produce papers and manuscripts. Like initially the birch bark or the burj patra, it was used for writing. An example can be seen here from a 17th century context from Kashmir, how a birch bark manuscript was used for writing. Also palm leaves, in South Indian context we can see extensively the use of palm leaves. They were used for writing and recording various events. The ink which was used for writing, it was a finely ground charcoal powder with the medium of gum or soot from oil lamps. So these kind of traditional and easily available materials were being used for writing and making manuscripts and all materials to record the history and also to maintain certain documents, administrative documents. Paper emerged lately. I mean, as we all know, paper, it was invented by the Chinese, but in Indian context, it appeared only in the 12th century, and it's unknown how this technology emerged into India. But the earliest paper manuscript, which is now preserved in the Ashutosh Museum in Kolkata, is datable to 1105 CE, and it was made from the fibers of a mountain plant. Paper manuscript, they retained the shape of palm leaf manuscripts for some time, and in a voyage to Surat in 1689 by J. Wovington, he describes the long scrolls of paper 3 meter in length and 30 centimeter in width, which were smooth and very slick and shining. So it records how the Indian paper was produced, and several other European visitors from 15th to 18th century, they also testify the Indian paper of very high quality and even exported to countries like Persia. So in the 19th century, handmade papers declined after the emergence of paper mills introduced by the Britishers in India. So this is an example of a paper manuscript in which the Rig Veda was written. It is datable to the 19th century CE. It's an excellent example of how a book form of manuscript can be maintained using a paper in ancient India. Textile is another important component, because without the textiles, no dress materials can be prepared, and we have excellent evidence of availability of textiles right from the Harappan context, and even before that, the presence of cotton seeds at Mehergarh, it is a clear indication that the cotton was grown by the inhabitants and it could have been used for producing threads and ultimately textiles. We have impressions on terracotta implements and terracotta objects from Harappan context in which certain textile impressions are found. The impressions and the available textile remains from the beads in metal beads, because the metal salts, they help in the preservation of carbonic remains, and that's how the thread used to string a copper necklace, it is well preserved inside a copper bead, and if it is viewed under a scanning electron microscope, the different morphological features can be very easily useful to understand which species it belongs to, whether it is a silk or a cotton or a jute, it can be easily identified. That's how the textile from Harappa has been identified, and recently in Dholavira also the cotton or jute fabric has been identified. We also have references to the ancient literature about the textiles, like the Rigvedic literature. It refers to various clothes. Cotton, it is mentioned as karpasa, to weaving and looms. From the Buddhist literature also we have various kind of references how the Amrapali was wearing a semi-transparent sari, and it speaks high volumes about the excellence in art. Also from the paintings from various places, like in Ajanta we have excellent murals which depicts various kind of dress materials, transparent to semi-transparent, to kind of high quality textiles worn by the royal and common people, that can be very easily seen from these paintings. So these are all examples of the paintings from Ajanta, the mural paintings which have evidences of the textiles and various dress materials. And India was an important exporter of cotton as well as silk during the Roman trade period in the early centuries of the Common Era. And hordes of fragments of cotton material from Gujarat were found in the Egyptian tombs. That is an important evidence coming from around 5th century CE, and a photo is also shown here. One can see the kind of things that was exported, and India exported cotton to China, silk to Indonesia, and also to the Far East. So the Indian textile industry was largely destroyed by the colonial rule, mechanization of the weaving, like the large mills they appeared, and slowly the loom industry it started to disappear. The textile part, other specialties of the Indians are the muslin, the calico, and the chintz. They are other types of textiles which were also mastered by the Indians, and it also supplied all the way to the western countries, and all exports were made from Indian region. So this is an example of a chintz kind of fabric produced from the Coromandel course datable to the 18th century. And traditional handlooms from various parts of India are clear indications of how the ancient system could have been existed. Indian textile industry is also famous for the dyes, various kind of dyes it was using to be used for the textiles to produce various kind of colored threads and also designs. One such is madar, a wine that yielded a red wine. Indigo is the most famous plant which was planted on a very large scale in the late 18th century in India, eastern India. The dye was mostly exported to Europe, but we have early evidence of indigo plantation also in India, and it was also exported to other parts of the world. So we have different examples, other examples coming from various periods, like this is an example from the Mughal period, how the block print on cotton, 2-panel door cover, it was manufactured in the Mughal period, and various floral motifs were used in this block printing, which is another kind of technology available during that period. So various kind of cosmetics were also in existence. One of the literary work, Vidya-mitra, describes the manufacture of perfumes, especially for the royal personages and the harems. The scented water for bathing, scented hair oil, scent to aggravate passion, perfume for clothes, for mouth, scented toothsticks. So all these kind of things were in existence, and different types were specified, and different quantity also are specified, how much quantity to be used for various occasions. So this kind of highly sophisticated manufacture of cosmetics were also available during the ancient Indian context. One more important aspect that can be attributed is the weather prediction. I mean, it could be one science that predicted what kind of weather would prevail. So based on the folk traditions, we know what kind of blooming patterns are emerging, that is predicted by the Todas of Nilgiris. So they just observe and tell about the blooming patterns. Vidya-mitra's Brihat Samhita, it has chapters on weather prediction, how to predict weather based on the observation of the movement of clouds and the type of clouds. So from that they were predicting the weather. The Panchangas, they were also developed to give the yearly prediction for weather, combining and these data with the astrology. There is also evidence of ice making in ancient India. I mean, if you look into the older records, we know that the Mughals, they manufactured ice and stored in an ice house each year from November. One of the important evidence is that they mention about a large hole 6 to 7 feet deep with raised sides, filled with dry straw for 4 to 5 feet, over which new terracotta plates are placed. The dishes are filled with water in the evening. Ice forms 2 to 3 hours later. The ice production is renewed 2 to 3 times in a single night. Plates are then broken and ice lumps welded together with water and stored in ice rooms for the rest of the year. So this kind of traditional manufacture of ice is mentioned by travelers who were visiting India during the Mughal rule. This is an account of one such a traveler datable to the late 18th century. Coming to the conclusion part, I mean, we have looked into the various kind of technologies present in the ancient Indian context, starting from the agriculture, development of various kind of crop patterns, then metals, then pottery, ornament making, jewelry making. So all this kind of mundane things, even mundane things, it involves certain kind of understanding of the technology. So Indians, they were perfected advanced technologies even before centuries before Europe in certain aspects, and a flourishing industry was there in the Indian subcontinent when the European traders arrived. That's how they were attracted towards the Indian technology, Indian products being developed in this part of the world and supplied to the entire region. Some even remain useful today, like Ayurveda, organic agriculture, metallurgical techniques, water management and irrigation, textile and crafts. Even today we study more and more about the traditional technology, and we try to understand and we try to market them also. So there is still a lot of scope for documenting, assessing and streamlining some of this traditional knowledge system. And if we don't understand this traditional knowledge system and if we allow them to die, then we can never understand the kind of technology available in the ancient period and which largely contributed to the emergence of the present day technology. So in that context, we have to preserve this traditional knowledge system so that we can better understand the present technologies. For more information, you can look into the other quadrants of this module in the EPG Pathshala by visiting the website